Good morning, everybody, or afternoon, or evening, whenever you're watching the video. We're going to start in chapter 15. I started in chapter 15, a little bit of trig with chapter 15. Today looks like we're going to talk about right triangle-based definitions of trigonometric functions. We're not going to do that one there, and we're going to do trigonometric function values of special angles. So 30, 60, 90, 45, 45, 90. Going to want to have your notebook handy today because we're going to draw a lot of triangles that you need to make sure that you know and understand and have handy for your assessments that you are going to take. So we're going to start out with just our basic trig we've talked about before. You've talked about before. We're going to add secant, cosecant, and cotangents to our sine, cosine, and tangent. We talked about them in Algebra 2, so it should be somewhat similar. Yeah. You should kind of maybe remember. I don't know. Maybe. So right triangle based definitions for trig. So sine. So when we're talking about sine, cosine, and so on and so forth, we're talking about different pieces of a triangle. So if you look down there at the triangle down there at the bottom, if we're trying to find the sine of angle A, you can find the sine of any angle. Obviously, we're not going to do it for right angles because what sine's doing is it's looking at different ratios of different sides of triangles. And the ratio for sine, sine is opposite over hypotenuse. So the ratio for sine is the length of the side opposite the angle that you're looking at over the length of the hypotenuse. The hypotenuse is always going to be the longest side of your triangle and opposite the 90-degree angle. The side opposite is the side furthest away from the angle that you're looking at, so it's kind of not in contact, and we talked about that in other lessons. So the sine value is the length of the opposite side. In this case, in this drawing they have down here, that's y over the hypotenuse r. So sine is opposite over hypotenuse, SOH. Well, there's another trig function that goes with sine. That's what we call the cosecant. And the cosecant is essentially the reciprocal of the sine. So instead of being opposite over hypotenuse, the cosecant of A is hypotenuse over opposite. And it's just a ratio. It's going to help us find the measure of an angle eventually. But it is just the length of the hypotenuse over the side opposite, and that's the cosecant. So we've got sine opposite over hypotenuse, cosecant hypotenuse over opposite. Oops, I think I skipped one. Now the next two that we have are cosine and secant. Cosine of A is the adjacent over the hypotenuse. So in this case down here of the drawing, it's going to be x over r. Adjacent is the side that kind of helps make up your reference angle or angle that you're referring to. And kind of keep in mind that opposite and adjacent can change depending on what angle you're looking at. If you're looking at angle A, x is the adjacent. If you're looking at angle B, y is the adjacent. So it does change a little bit based on what angle you're looking at. And again, you're never going to look for adjacent in that for the right angle. So cosine is adjacent over hypotenuse. Sine opposite over hypotenuse, cosine adjacent over hypotenuse. SAH, Well, the other one that goes along with cosine is secant. Secant is the reciprocal of the cosine, so it's hypotenuse over adjacent, and that's what the secant is going to be. Okay, so we got sine, cosine, cosecant, and secant so far. There's two more, tangent and cotangent. Well, that kind of makes sense. So tangent is opposite over adjacent, over A, and cotangent, reciprocal, is A over O. And these are just different ratios that we have to be able to do and assign to different right triangles. And again, remember, it all is based off of kind of what we call a reference angle, or what angle that we're looking at. And we want to be able to write these different ratios, and we want to be able to write exact values, so as fractions or as decimals, whatever the directions tell you that you're going to need to do. And we're also going to look at what happens with these with special different types of triangles in the lesson today. So let's look at a quick example. It says find sine, cosine, and tangent for A and B. So we're going to start out by finding the sine of A, the cosine of A, and the tangent of A, and we're just going to write the ratios. So I identify my angle. There's angle A. if you need to, label the sides, label the sides. The 24 is going to be adjacent because it makes up the angle, but it's not the hypotenuse because the hypotenuse is 25. Hypotenuse is the longest side, and it's the side opposite the 90 degrees, so that makes this the opposite. So I've labeled the sides. Now we're just going to write the ratios. So sine of A is opposite over hypotenuse, so 7 over 25. Cosine of A is adjacent over hypotenuse, so 24 over 25. And tangent of A is opposite over adjacent, so 7 over 24. So there's sine, cosine, and tangent of A. We also want to be able to do the sine, cosine, and tangent for B. So we're going to go the sine of B, the cosine of B, and the tangent of B. So the sine of B, so now we're looking at this one. So this isn't adjacent anymore, and this isn't opposite. Now this is adjacent, and this is opposite. Hypotenuse stays the same. So sine is going to be opposite is 24 over hypotenuse 25. Cosine is adjacent over hypotenuse, so adjacent is 7 now over 25. And tangent is going to be opposite over adjacent, so 24 over 7. Okay, and you'll notice these ratios are the same, these ratios are the same, and those are just reciprocals of each other. Okay, so there's the sine, cosine, and tangent values for both A and B. So label them in accordance to the angle that you're looking at, and then go kind of from there. And there's their solutions. Okay, I'm going to go back to here, and we're going to do one more thing with it. So now let's do the secant, cosecant, and cotangent for A. So here's A. So this is my opposite, this is adjacent, and this is hypotenuse. And now we're going to do the secant, cosecant, and cotangent. So the secant is the reciprocal of the cosine. S goes with C, C goes with S. So secant is the reciprocal of the cosine. So cosine is adjacent over hypotenuse. So this is going to be hypotenuse over adjacent. That's the secant. Cosecant is the opposite of the reciprocal of the sine. So hypotenuse over opposite. So 25 over 7. And the cotangent is the reciprocal of the tangent of A. So tangent is opposite over adjacent, so this is adjacent over opposite. So there are your secant, cosecant, and cotangent ratios. Just remember that sine goes with cosecant, cosine goes with secant, and tangent, the one that makes sense, tangent goes with cotangent. And they're just the reciprocals of those. Right? So there's sine, cosine, and tangent. The next thing we're going to talk about is we're going to talk about two special types of triangles. We're going to talk about 30, 60, 90, and 45, 45, 90 degree triangles. And these are just doing the proofs for them. We're just going to kind of skip proofs of them because those are just the proofs. And we're going to talk about this piece right here. So this triangle you need to draw. And this is kind of always the triangle that we are going to use. It's a kind of a 1 to 2 to the square root of 3 triangle. And this is the triangle that we're going to create anytime we have a 30, 60, 90. So this needs to be in your notes and you need to label it. So the side opposite your 30 is always going to be labeled 1. And we're going to do a lot of things with this. So you always want to label that 1. The hypotenuse is always going to be labeled 2. And the side opposite the 60 is always going to be labeled the square root of 3. You want to have this down. This wants to be circled because this is going to be used a ton now. Because we're going to find the 6 trigonometric values of this. Okay, so I'm going to erase my drawing of it just to give you time to do it. So we are going to find the sine of 60 degrees, the cosine of 60 degrees, the tangent of 60 degrees, the cosecant of 60 degrees, the secant of 60 degrees, and the cotangent of 60 degrees. And we're going to write those ratios, and these are exact values. And these are always going to be the same no matter what the 60-degree triangle looks like. Okay, so here's my 60-degree angle. This is opposite, this is hypotenuse, and this is adjacent. So sine is opposite over hypotenuse. So the sine of 60 is going to be the square root of 3 over 2. It's always going to be the case with a 60-degree triangle. Cosine is adjacent over hypotenuse. So that's going to be 1/2. The tangent of 60 degrees is opposite over adjacent. So that's the square root of 3 over 1. There are your exact trig values for a 60-degree angle. It doesn't matter what 60-degree angle is, that's what it's going to be. Okay. Cosecant. That's the square root of 2. That's 2 over the square root of 3, but we can't leave it like that. So we have to multiply by the square root of 3 over 3. So the cosecant is going to be 2 times the square root of 3 over 3. That's what the cosecant is always going to be. The secant is the reciprocal of the cosine, so the secant is 2. The cotangent is 1 over the square root of 3. But again, we can't leave that like that, so we have to multiply by the square root of 3 over the square root of 3. So it's the square root of 3 over 3. So that's the square root of 3 over 3. So there are your solutions for the 6 trigonometric values for a 60-degree angle. And that's always what it's going to be for a 60-degree angle, or anything that can be associated with a 60-degree angle. And we'll talk more about what I just meant there in just a little bit. Okay. So let's look at those. There's theirs, there's theirs, there's theirs, there's theirs, there's theirs. Same exact values that we had for all of them. Okay. The next type of triangle that you need to have down is you need to have down the 45, 45, 90. And it says use the Pythagorean theorem to solve for r. It's already done. So I want you to go ahead and draw this triangle, a 1 to 1 to the square root of 2. Okay, for a 45, 45, 90. And again, these are always going to be the ratios that we're going to use for a 45, 45, 90. So when you're asked to find the sine of a 45-degree angle, we're going to label them like this. 1 to 1 to the square root of 2. Okay, and they're going to go through a proof of this probably when I start clicking. But I just want you to get this copied down. 1 to 1 to the square root of 2. Your hypotenuse is the square root of 2. The other ones are just what they are. Again, this is just the proof. Okay, so now we're going to find, let's see if I can. Okay, so we're going to find the sine, cosine, and tangent. So I'm just going to scratch those out. So we're going to find the sine of a 45-degree angle, the cosine of a 45-degree angle, the tangent of a 45-degree angle, and we're going to find the cosecant, secant, and cotangent of a 45-degree angle as well. Okay, so we're going to look at this one. Secant sine is opposite over hypotenuse. So that's 1 over the square root of 2. Can't leave it like that. So we'll multiply by the square root of 2 over 2. So it's the square root of 2 over 2. That's the sine of a 45. Cosine is adjacent over hypotenuse, which is going to be the same thing. 1 over the square root of 2, but we just learned that that's the square root of 2 over 2. Tangent is opposite over adjacent, so 1 over 1. So 1. Cosecant, it's the reciprocal. And now just do the reciprocal of the original. The original, it's the hypotenuse over the opposite, so that's just the square root of 2. Secant's going to be the reciprocal of the cosine, it's just the square root of 2. Cotangent, the reciprocal of the tangent, then it's just 1. So there are your different solutions for a 45, 45, 90. So now it really doesn't matter kind of what I give you. You should be able to express them as either 45, 45, 90 or 30, 60, 90s or so on and so forth. So they're going to go through really what we just did. So we've got this special functions table of special angles. If you can memorize this or write it down, it's going to make your lesson a lot easier. You're probably not going to memorize it, But I would go ahead and copy this table down. Press pause right now on the video and write that down, because a lot of your questions today are going to say, give the exact value of the sine of 30. Sine of 30 is 1/2. You're done. Nothing left to do. What's the exact value of the secant of 45? Well, it's the square root of 2. You've got it in the table. You can look it up quickly and you can be done. Press pause, write it down. All right, so a couple other things that I want to talk about, things that you may have to do today. You may be given two sides of a triangle. So they may tell you that this length is 3, this length is 4. This is angle A. It might ask you to find the sine of A, the exact value of the sine of A. Remember how you find the third side of a right triangle, Pythagorean theorem. 3 squared plus 4 squared equals 5. Well, it's going to be 5, but x squared. So 9 plus 16 equals x squared. 25 equals x squared. X equals 5. So we know this is 5. So the sine of this would be 3/4. Okay, you've done that before. So you may have some of those. You're going to be asked to find exact trig values. And those exact trig values, just use that table. The other thing it's going to ask you to do is going to ask you to determine what is bigger. The secant, say, of 13, it's going to ask you if this is true or false. Or the cosecant of 13. Okay. Remember, the secant is the reciprocal of the cosine. So the secant of 13 is the same thing as the cosine of 1/13. So you can punch that into your calculator. Can't punch secant into your calculator, but you can type in its reciprocal. So if I go the cosine of 1 divided by 13, that gives me like 0.99999. If I go the cosecant of 13, that's the same thing as the sine of 1/13. So I hit sine of 1/13. It's 0.00. So this one is greater than that one. So it'd be a true statement. Okay, so you're going to have to look at those today. And just kind of keep in mind that it's kind of that reciprocal piece of it if they're giving you ratios for that. I think that's pretty much what you're going to have to do today. Is going to ask you for exact values in there. It's going to ask you maybe for a couple other things, but yeah, just exact values today with 45, 45, 90s and 30, 60, 90s. And if you get that table memorized, you should be good to go with today's assignment. So 15.1 is done. Next lesson is going to be 15.2, and then we're kind of looking at a quiz the day after that. So we will see you next time.